Kinetic energy, mass, speed, and graph. Why is understanding energy important? Knowing how energy works helps us understand the machines and engines operate. Athletes improve performance to design safer cars. Renewable energy works and how objects move in space. So, energy concepts form the foundation of physics and engineering. So we'll learn about what is kinetic energy and how mass and speed affect it, and construct and read graphs that show these relationships. So what is kinetic energy? Kinetic energy is the energy of motion. Anything that moves has kinetic energy. For example, a running dog, a flying airplane, a rolling skateboard, water flowing in a river. So here is a formula that is kinetic energy half time mass time speed square. So that means here is a what affects kinetic energy, that is speed. The faster something moves, the more kinetic energy it has. And mass, a heavier object has more kinetic energy if it moves at the same speed as a lighter one. So here is a formula that means that a speed has a bigger effect because it's squared. If a speed stays the same, more mass, more kinetic energy. For example, here's a truck versus a bike rolling downhill at the same speed. The truck has more kinetic energy because it's heavier. If mass stays the same, so that means faster speed, much more kinetic energy. For example, a sprinter versus someone walking, same body, but the faster speed makes kinetic energy. Here's some graphs, that is bar graph, line graphs, or scatter plot. So bar graph, that is compare kinetic energy at different masses or speeds. Line graph, that is shows how kinetic energy changes as speed or mass increases. And scatter plot, that is for real data points. All right, let's build one. Here's a mass stays the same, so 1 kilogram ball. So that is a speed tested 1 meter per second, 2, 3, or 4 meter per second. Here's a plot that is x-axis speed, that is meter per second, y-axis, that is kinetic energy joules. So what does the line look like? Is kinetic energy increasing or decreasing? Does doubling speed change kinetic energy? And what does the slope tell you? Here's a quick practice. If an object's speed doubles, what happens to its kinetic energy? If an object's mass doubles but the speed stays the same, what would that look like on a graph? Kinetic energy depends on mass and speed. More mass, more kinetic energy, and faster speed, lots more kinetic energy. That is the square. Graphs helps you to see the relationship. All right, guys, that's all for today. Thank you, guys, and see you very soon.